So my name is Elizabeth Stuffings. I'm an instructor with the Telluride Institute's Watershed Education Program. And Vicki here is one of the co-directors of WEP. And yeah, we're really thrilled to be doing the Valley Floor Living Classroom again in 2018. So we did have the same programming in 2015. And really we recognize that there's a need for adult science-based education, tours, field trips here in Telluride. So we're really excited to use the Valley Floor as our classroom to accomplish those goals. And today specifically, we're going to be getting out on the San Miguel River and Prospect Creek and checking out the water resources, the aquatic life, and really getting hands-on. We're going to actually produce some data and some samples that we're going to send to labs for analysis. So I think that's really exciting that we're going to be really engaged in citizen science today. And so in addition to my work with the Watershed Education Program, I work with the San Miguel Watershed Coalition, and we have a pretty robust water quality monitoring program that spans the whole San Miguel watershed from the headwaters all the way down to the confluence in the west end. And then we're super fortunate to have Justin Pomerantz with us today. I'll let you do a quick intro, Justin.
Yeah, hey everybody, my name's Justin Pomerantz. I live over in Montrose, and I'm an aquatic entomologist and community ecologist, and just happy to get out and help out and show you guys some bugs, and we'll take a look at some of them, so it should be pretty fun.
So back in 2014, the town and the state, they started a project where they wanted to really look at what's in these tailings. Are they a concern? They're right on the river. Do we need to actually do something about them? And so they, over this 25-acre area, they put in about 25 plots, and they did really comprehensive soil testing. And let me see my numbers. So I think the tailings are relatively shallow. They only go to about 24 inches to 40 inches deep. So not terribly deep. Piezometer in particular, let's see, I want to say, so there's 15 on this 25-acre parcel. And these pipes, they go, I think, upward of 50 inches deep. And some of them hit groundwater, the water table. Some of them didn't. And so the 2014 was that first push to really quantify what's out here. And they were looking for and found concerns with arsenic, cadmium, copper, zinc, and lead. So there's the potential maybe in the future that a remediation process could occur here. And so here they're monitoring the groundwater. And so as I understand it, these piezometers, when they're read, they're able to look at essentially the pressure that's exerted by that groundwater, and they can read the depth of the groundwater. And the point of that is to understand how water is flowing through the tailings, and then if that water, when and where is it hitting the San Miguel, and then we can go in and sample at those spots on the San Miguel and see how much arsenic from this tailings pile is impacting the river and then aquatic life. So we're gonna, here at our site on the San Miguel, we're gonna look at the water quality, the aquatic life, and then time permitting, we are also gonna go just up on maybe a 5-minute hike up to Prospect Creek. Because if we have time, I think it'd be really great to do a comparison of what we're seeing on the river versus the creek. So first then, here at this first site, what we're going to do is we're going to both test the water with our meters, and then we're going to actually do some samples. And we're going to sample for heavy metals, and we'll go through the process of filtering the water, etc. So let's get started with some of our field parameters. So we have this super handy multimeter, which does the work for us. And so we're going to specifically be looking at temperature, pH, dissolved oxygen, and conductivity. And we'll get this in the water, and we'll talk about each one of those parameters as we're doing our readings. So, so we have our standard data sheet, and this comes from the Colorado Water Quality Control Division. And so, one of the big things to keep in mind as we're doing our water quality testing is to make sure we have quality control measures in place to make sure the samples we're getting are valid, and so that any decisions that are made on the data, which could potentially be pretty big decisions, like do we need to do a restoration project here to support wildlife, etc., comes from the data. So we do a lot to make sure our data is sound. So what we're going to be specifically looking at are our field measurements. So once again, temperature, conductivity, pH, dissolved oxygen. So these meters, they're calibrated, so they should be good to go. And if you guys want to just walk them out into the river there. And so we're going to be looking at pH and conductivity first. So so this makes their life really easy. And we'll let these, it takes a little bit to record the parameters, but we'll get those readings here in just a sec. So I want to talk about a little bit about why these specific things we're testing and why they're important. So for pH, that's a big one for us, especially up here in the upper watershed with some of our acid mine drainage issues. And so the Watershed Coalition, we test about 38 sites on the San Miguel, and on average the pH for the river and all the various tributaries is in the range of like 7.1 to maybe like 8.8 or so. And I've heard like a really general range for pH that aquatic life can persist in is roughly 6.5 to 9. So that's kind of what we're looking at for a healthy range. And so most of our tributaries in the river fall within that range here on the San Miguel, but we definitely have some hot spots, especially up around Ophir right now. So say for instance, Iron Bog Creek, which as you're going up Ophir Pass, just outside of town, is that really iron-rich stream that crosses the pass. And I was up there yesterday testing, and the pH is about 3.5 up there. So pH, so it's a scale of how acidic or basic a substance is. So we're looking at the low end of the scale, so readings around like 1 would be very acidic. And as you go up to 14, you have very basic substances. And 7 is neutral, and so our blood is a pH of 7. And so that's, generally that middle range will support aquatic life. Another concern with pH is sometimes if we have these really extreme pHs, they make the metals in the water more soluble, so they're more readily absorbed or taken in by aquatic life or deposited in sediment. And so then briefly, just to touch on conductivity, that's how much of an electrical current water can conduct. And so we're looking at conductivity to, in some cases, looking at the relationship between conductivity and salinity. So generally, the higher the conductivity, the more salt we find in our streams and river. So I'd imagine, like on the Dolores River, as it runs through Paradox Valley, I would have to guess that has a pretty high conductivity, since that valley's a salt dome collapse. And then, especially when there are acute introductions of pollution, you'll see pretty high spikes in conductivity. So it's an indicator of pollution issues as well. And in our testing, we generally see conductivity ranges from about 100 all the way up to about 1,200 here in the San Miguel. And some of those higher readings are associated with some of the problematic streams up in Ophir. So this number is our pH, if you just want to read that number out loud.
7.21.
7.21, yeah. So pretty good. And then this number right here is our conductivity.
Okay. 198.8.
Yeah, perfect. All right, and we'll just swap out one of our meters and get our dissolved oxygen real quick. So dissolved oxygen is the amount of oxygen that's in the water and available for aquatic life to use in respiration.
And if you had water that was just sitting there with no agitation, you're figuring about 1% oxygen, dissolved oxygen. The air is 21% oxygen, so the more agitation you have along that surface, you're going to get oxygen incorporated into the water.
So that's why you'd want a bubbler in a fish tank.
Yeah, exactly.
Yeah.
Some of the concerns that we have here on the San Miguel would be in some of our reservoirs like Woods Lake, Miramani, and a little bit in the West End with some agricultural concerns of the introduction of fertilizers in runoff. And you then get algae blooms, and as bacteria decomposes the plant life that blossoms, they use up all the oxygen, or a large amount of oxygen in the water, and so you have concerns of oxygen not being available for fish and insects.
One of the reasons why we want to look at bugs is for water quality and like kind of the community health, especially in this part of the country. Like right now we looked at the water quality and it's pretty good. Like everything seemed like it was in normal, but remember where we started out at the beginning on that tailings pile? So especially here, like during spring runoff, you've got water moving through, like actively being flushed through those tailing piles and coming into the water. And so but the bugs have to be here all year long, right? They have to live their whole lives here. And so you can actually detect those kind of flushes of, you don't know when it happened, but you know that it did happen. So like if we had the pH of 7.2 or whatever it was, and like everything's looking good, we would expect to find some of the bugs that are on that sheet that Vicky was passing out. But if we go out and sample and we don't see those, that's kind of an indication of, maybe there's something going on, or maybe there's, maybe one of the mines further upstream is putting stuff into a tributary, and that's like coming down here and actually affecting it. So maybe the valley floor here is clean, but we've got other issues going on. The watersheds are all connected. A lot of people think about how important the bugs are in the water, like for fish. That's where most of the money and most of the interest in bugs is fishermen and anglers. But really, they're actually a very important resource for all the birds and bats and lizards and spiders, depending on what part of the country you're in. So earlier there was a big swarm of birds flying around. You can kind of see them swooping, and I'm almost positive they were going after adult insects that were emerging out. And so that's another thing that is really important about bugs, is it kind of connects these two, what we kind of think of as like different disconnected landscapes. We don't really think of the trees and the forest being like a part of the water, but really it's kind of a double connection and kind of links those things together. And so, anyways, so moving on with the bug. Oh yeah, here we go. There's a little mayfly larva there, probably like a Drunella. See him kind of crawling around there. Everybody see that?
Oh yeah.
Yeah, big old guy, and there's another one there. So this is what's called a caddisfly. This is a
Oh, good for you.
Glossosoma.
Yeah.
So it makes a little, if we kind of, I'm trying not to kill him, but if we like flip him over, you can see that little thing crawling in there?
Yeah.
So that's a tiny little caddisfly larva, and then when they emerge, they kind of look like a moth. They're actually like related to moths and butterflies. But you'll see them kind of fluttering around. They're kind of more active at night as adults. You don't see them as much, but that's a cool one.
Yeah.
They call that the saddlebag case caddis because they often have really big ballast stones on their sides. So it looks like kind of like they're wearing saddlebags. But so if we really want to catch a lot of bugs, and if we were doing like a quantitative sample, we would use something like this. And basically what you want to do, it's kind of deep there, so I'll walk up a little bit further, but you basically put this in the water, and you can imagine the water's flowing this way, and then if you just pick all the rocks up, all the bugs kind of get flopped up, and they just go right into the net, and then we bring them out, and we'll dump them into these things here, and we can sort them out and pick through them. So let me go get some bugs so people can start looking at them.
All right.
My boots are full of water, but that's okay. So in really riffly, fast-moving water like that, a lot of times, this is one of those things that you found. You really want to dig down into the water because they just kind of get down in there for protection. So we'll just dump some of this out. A lot of rocks. So see. Once you kind of let them settle out a little bit, you kind of want to spread them out without getting too muddy. And so we've got some forceps here and some little ice cube trays. So if you want to start picking out the things that like look similar and just kind of throw them together, you know, like there's a nice big mayfly. There's another one. And then we've also got keys here. We've got these nice picture keys you can kind of flip through to try and ID stuff. And we've also got some more kind of classic dichotomous keys there. So if people want to start kind of doing that, I'll go try and find some other bugs, and I'll be right back.
And besides using the ice cube trays to sort the different kinds, some of them are predatory and they might start eating each other as well. We've had that happen before.
So here's a really big caddisfly, a bunch of mayflies.
I think we're going to have some luck down over there because I saw some just in a rock the other day, a bigger rock.
There's a big. So this guy, see how he's he's got that line down his back?
Oh yeah.
He's actually about to emerge. Like that's so when they emerge, they split down the back.
So that's not complete metamorphosis, right? It's not.
This one's not. No.
Yeah.
Exactly. So I bet actually if we let that sit there, he might. He actually might
Do you
emerge.
See the gills are. Can you see the gills moving there?
Flapping.
There's a big one.
Yeah, that's the same type.
And
But
what
you can see
what,
he
what are we
doesn't-
looking at there? What type of?
So I believe this is Drunella grandis. This is a mayfly. This is one of the sensitive species. But you can actually see how he doesn't have the line on his back? Right. So he or she is a little bit younger or not quite as ready to emerge. Maybe if they'll both flip over, you can kind of see them compared side by side.
What'd you find?
An adult stonefly.
An adult stonefly.
Oh, great.
So this is the family Chloropurlidae. I think the fishermen call them like green sallies or yellow sallies or something like that. Yeah, so that's a little stonefly. Adult. Unfortunately, I haven't seen any of the larvae yet, so can't compare it, but they're pretty.
Oh, that's two guys right there. That's,
No, it's
or is that
actually
just one? Really?
Yeah.
Oh, wow.
Oh, but here's a. So here's a cased caddisfly. This guy here, this is Brachycentrus americanus. If you look at them up close with the hand lens, they build a case that's like it's like perfectly squared little. They call them the log. It's this guy. They call them the log cabin case makers because their case is just kind of like a perfect tapering square. Sometimes you can find really cool stuff kind of like on the edges of the cut banks. So I'm gonna go see if I can like kind of underneath this kind of eroding riverbank here. If you go kind of dig underneath there, you can find.
Yeah? Oh my goodness, lots.
Yeah, you can definitely depends on where you get them. These guys are super cool. That's actually what I'm kind of looking for. They're some of my favorites.
What's this guy? Is that another one? I think
So,
it is.
is there a chance,
Or is that
Justin,
the
that
same?
you could?
That's actually a mayfly.
Ah, let me get him
Yeah.
out of there.
So that's a family called Heptageniidae, called the flat-headed mayflies. Those ones are super sensitive, and if you find those, it's it's a pretty good indication that your stream's in good shape.
Most of the mayflies have 3 tails.
So if it has 3 tails, it's definitely a
Definitely
mayfly. But
So
a
what
lot of them
else?
have 2.
What I always tell the kids is think of an M for mayfly.
Oh yeah, that's a good.
And we stick our fingers out like this, and that
That's a good
reinforces
idea.
it.
So these caddisflies go through complete metamorphosis, like a butterfly. Speaking of, there's one. So it's basically like their version of a chrysalis. So like they go from a larva like this, and then they enclose themselves in this little pupa and completely metamorphose into an adult, and then the pupa actually can swim to the surface, and then it'll split, and then they'll fly out from there.
Whereas this guy, the one that's splitting here, that mayfly,
The mayfly.
it doesn't have complete metamorphosis, right? It goes.
That's correct. So it basically doesn't have that chrysalis stage, and it just goes straight from that to
Do you want me to
its
move
adult form. And you can usually you can tell because you can kind of see the wing pads on these guys. And so like the stoneflies are the same. You see those big. Let's see if there's a good picture on these. It's not the best illustration, but you see these little like spiky things sticking out. Those are actually their wing pads, so they're developing as a larva. Whereas the ones that go through complete metamorphosis, they don't have any kind of wing structure until they're an adult. Here is Arctopsyche, and it does this. It builds, so it's got a little like retreat here, and then so they can get that kind of greenish color that I think Vicky was talking about. See, like under their abdomen, they're kind of greenish. These ones are super sensitive. Like this whole family, basically, if you find one of these, you know your stream's in like relatively good condition.
And say the common name of that one again.
So I think the common name would be a flat-headed mayfly.
Okay.
That's the common name I know. The scientific family is Heptageniidae. This is all one type of mayfly. This is all one genus. Well, not that guy, but like these. This is Drunella.
Okay.
And actually, this is Drunella grandis. You can actually ID those pretty easily, just because there's not that many of them. So did you guys all see that adult stonefly that we found crawling around? I think that's actually what these are.
He's still in the.
He is. Oh,
Same
awesome.
family.
You've got Swelza, Sualia, and then
Could be
2
Sualia.
unknown. One that's in the
So what did you find?
Captivity family.
Okay.
Can't really
Another
identify
unknown
it. It's
in the
just the head.
chloro.
Do you think maybe what's that casing suggest
I
it
think
might
it's
be?
a caddis.
Yeah.
Yep. So these are all. So that green, that adult.
Can you
we saw
hold them
was
up
kinda
for me again?
greenish Yellow.
Just-
Definitely in
just
this
show me.
family.
Okay.
Okay.
Probably Suwalia,
Beautiful.
and that's kind of what these look like as well.
Good job.
But so generally speaking, the EPT is the E is Ephemeroptera, which is the mayflies. The P is Plecoptera, which is the stoneflies, and then the T is Trichoptera, which is the caddisflies. And that's mostly what we're finding here. Like they're kind of the big, and like broadly speaking, those are the sensitive groups. But those are orders. So those are like really big umbrellas that incorporate a lot of different families and genera within those. And so, generally speaking, if you find stoneflies, caddisflies, and mayflies, your stream's in like, you can kind of say it's in like relative. If you don't find them, then you know it's like bad. But even within that, you can get different kind of sensitivities within the group. So like the mayflies are kind of the classic like sensitive species indicator. But like I was saying, there's this group Betis, which like, you know, if you don't find it, your stream's definitely probably in like not great condition, but you can find them in relatively polluted, impacted streams. So there's kind of differential sensitivities to those things, and it also depends on what pollutant you're talking about. So like within the stoneflies, like there's some groups that are super sensitive to metals and other ones that aren't really that sensitive to metals, and like caddisflies too. Caddisflies I'd say are kind of more generically tolerant of the three, but again within that, certain species can be super sensitive to certain issues, whereas others might be a little more tolerant of that. And so like the tolerant groups that you usually find, we haven't actually seen a whole lot of. There's these little black flies here, these little black fly larvae. So those you can kind of find anywhere. If you don't find those, there's something either really bad going on, or you're just in the wrong, or it's too hot. I would say actually, you know, like if you're down like lower, it might just be too warm or something like that. And then somebody was pointing out there's these tiny little things here that they're really hard to see because they're kind of white. And so in these white trays, they're hard to see, but they're basically just, there's all these different kinds of true fly larvae. So they turn into, I mean, like, you know, not really mosquitoes in this kind of habitat, but you know, they would turn into mosquitoes or those big crane flies you see kind of on the side of the river. That's actually one thing that can be kind of tricky in a nice, like it's a very nice little section of stream here, but because it's kind of like a flume and you know, things just get moved down, and so like the having things to eat is the big thing. And so like I was kind of underneath those snags, you find like big leaf packs and grass and all these like kind of like organic things, and if you just kind of shake those out, bugs will just kind of be flowing off them. Whereas here, one of the reasons why they have to dig down is like things like, you know, like little twigs and sticks and stuff get caught under the rocks, and so they have to like dig down to find food. And actually the best habitat is probably that cut bank, because you've got really nice, cold, fast-moving, oxygenated water going by. And you've also got, you know, you've got soil coming in from the bank. You've got sticks and roots to grab things and kind of hold stuff. And so that's where we, a lot of these Terra narcella, the really big black stoneflies there, that's where I found a lot of those. And then there's this other type of cased caddisfly here that's got kind of more of the stony case. That's where I found most of those guys. So yeah, it just depends, like, you know, but you probably wouldn't find these mayflies that like being in the really fast riffles because they just don't really have the habitat, you know. So it's kind of this Venn diagram of like, is there food there? Is it the right habitat? Is it the right, you know? And then it's just kind of like all these different filters, and so you can find them in kind of just like different spots within the river. Adults, like throughout the summer generally, so they emerge as adults, they mate, they lay their eggs. Depending on the species, they might stay as an egg throughout the winter, or they might actually hatch and kind of like live in the water throughout the winter. But either way, they kind of spend basically an entire year from egg to adult, and then they emerge. And most of them are like, you know, I mean, some of the adults don't even have like mouths. They literally just mate, lay their eggs, and die. You know, I mean, that's why the mayflies, their scientific name's Ephemeroptera, which is like ephemeral and like short-lived. And you know, as adults, they might only live for like an hour, or, you know, 5 hours, and then they're done. And whereas like the stoneflies and caddisflies can definitely be around for longer, but they're still like very, very short-lived.
What is this?
Yeah, so this, that other caddisfly you just had in the case,
Yeah.
so that's what it looks like as a larva, and then what it does is it pupates. And so this is like a chrysalis, like, you know how butterflies, caterpillars go through a chrysalis and turn into a butterfly?
Yeah.
That's exactly what this guy's doing.
Huh.
So it builds a cocoon, and it stays in there, and you can actually, if you look really close, you can actually see its little legs. If in the sunlight, you can kind of see You got to look at it. It's kind of hard to see, but you can kind of see an abdomen with like 3 little legs sitting there, and so it just is gonna.
Why don't you look with the hand lens?
So that thing's basically gonna. It's actually amazing. The body basically dissolves and turns into like soup, and then reassembles itself as an adult, and then pops out from there. But one other thing about life cycle I wanted to talk about, these really big stoneflies, these guys, they actually can have a like a 2 to 3 year life cycle because it takes them a long time to get to that size. And I was mentioning their cousins in a different, so this is Terra Narcella, and there's another genus called Terra Narcis, which you can find down kind of in lower streams, and they can be, I mean, they can get like, you know, like the bigger than my finger, like they can get like really, really large, and they have like a 4 to 5 year life cycle. And the anglers get really excited about them because they have this big synchronous emergence. And I mean, you can be walking on, like the Black Canyon of the Gunnison has a really famous one. I mean, you can be walking and there's just these massive stoneflies just flying around everywhere, and they've got kind of a this like salmon-y color on their side. So the common name is the salmon fly. But they can be, so there can be ones that live longer than that. And actually some of the mayflies and some of the little Diptera, the little true flies that we were finding, some of those things can have like a week generation. Like they can just, you know, have like multiple generations throughout the entire summer. They just like pop up, you know, mate, die, and then like the egg within a couple weeks turns into an adult again. And so throughout the entire summer they can just be kind of like rolling really fast. I think that's one of the reasons why they can be found in like pretty polluted places too, is they don't need that much time. You know, they just need a little tiny window to complete their life cycle.
Cleaning they were doing.
That's okay. See what else we can find.
But he was born on, I called it, he was walking in the sands of Lake Michigan before he knew what grass was. And we discovered how polluted our waters were in that southern
more of those caddisflies, right?
area because all of the communities north of Chicago don't have systems to, when they get heavy rains, they just have to flood all of their sewage out into the lake. And it would collect right down where we had our summer home.
Oh my God.
And so we would sit there with the ramifications of it, of letting him play in the sand, until I realized that what is the sand but a filter for the water holding all of that bacteria.
Right, right. And probably heavy metals and everything else.
Oh, everything, yeah.
So we're gonna, just like we did on the San Miguel, we're gonna get our parameters again. So once again, pH, conductivity, dissolved oxygen, and see how they compare. And I'm in particular interested to see what we find because we test on Prospect, but way up in Mountain Village, and we test for nutrients to see if the ski area or the golf course is having an impact on the creek. So we'll also grab some metal samples as well.
Oh yeah, I don't think I'm actually doing good at all.
You can do 2 at once on this one?
Yes.
Yeah.
We've got our bottles over here, and we'll just go up above.
Okay, so it's stabilizing.
Yeah, for sure.
Multi-handed.
What'd you do, Jerry?
I was holding everything at
more
once.
like muddy almost.
Cap,
So it's like lower gradient, so it's not flushing all that fine sediment out. And
Pocket.
that's kind of what I'm saying down there. Is
like
like
by
you can probably
suction
find
with
leeches
one
down there, but you
hand.
just
It
gotta dig really
wasn't,
deep or just find like
very
different
fast.
habitats.
Yeah,
I didn't lose anything. I
it's
was,
easier
more
to
suitable for
fill it
them.
first and not have to suction it.
it didn't dawn on me to even try that. You know.
Yeah, in about a month or so, I'll have the lab results back. So I'll send those out to everyone with a little analysis to just let you know like how healthy is the river, how many metals do we have in the river, and Prospect Creek. So
We're doing a quick wrap up here because not everybody's going to be here.
yeah, so I'll be sending out the lab results in about a month or so, and I've got your email, so I'll get those out to you. And yeah, and all the data that we collected is going to go up into the EPA's database. So thank you for helping out today gathering that data.
If anybody wants to see one last bug, I just found an adult stonefly flying around. I'm trying to keep them from getting away. I'm not sure what it is, but yeah. See, like it's got big wings.
That's cool. Resemblance.
Yeah, right. Yeah, and so that's what we were talking about earlier with like the complete metamorphosis versus partial.
Right.
They kind of look the same as a larva, whereas like a caterpillar and a butterfly look totally different, right? So like that's kind of a good indicator of if it's full or not. I'll let him see if he flies
Oh, there he
away.
goes. There.
Yeah. Yeah, he's just hanging out.
Oh, that's a good shot.
Yeah.
It was right on the log.